Hey guys, thanks for tuning in to this week's episode of Revealed. This week we have something a little bit different. We're here in the shop and we're going to talk about something that was built in the shop, but it wasn't built by our shop team, it was built by our field team. So joining me today is Nick Yost. He's the project manager on this job, and he's going to walk through some of the features of this staircase with us and answer some questions that we have. This is our first shop built staircase.
Yep.
And you have built some really incredible, very challenging staircases in the field, including a recent elliptical bent lamination, all done in the field. Mm-hmm. How does this compare?
So this, although it looks like it's a lot, it was actually, I would say it's a little easier. The last staircase we built, the elliptical staircase, was definitely challenging, one, due to the shape and the geometry. You know, ellipse shapes are not easy to work with in the field. The second thing was the space on site. You know, we built our temp walls inside our opening, which I thought was a good idea at the time. It worked, but it wasn't the most ideal situation. Whereas here, although the shop is smaller, you know, we have access to different machines and tools here that we don't have in the field. The site that this stair will be going to is very small, and especially once we get into rough, there's just a lot of bodies and a lot of moving parts there. So it just really made the most sense to build this in the shop. And in doing so, you know, like you said, I did a lot of work up front in the design of this so that when we did get in the shop here, we could hit the ground running. You know, we were working with a tight budget on this one, and, you know, Nick and I got together and we kind of said, well, can we be competitive? And, you know, I said, I think we can, as long as we put the proper plan in place. I really think we can do a great job, and we can knock this thing out of the park.
Where do you start? Where do you begin with something like this? I see you guys fabricated some temp walls. We know that in the field, nothing is ever plumb or the corners aren't 90 degrees. How do you start with something like this here in the shop?
Yeah, so I'm going to step back a little further because, you know, this is a very large staircase, and the nice thing about this was I was allowed to design this based on an existing staircase that was in the home already. So a lot of the, you know, the dimensions as far as, you know, tread width and, you know, the winder pattern and even the well opening, you know, we have a 13-inch well opening here. It'll match the staircase below it. Now the project we're putting this in, it actually had two existing staircases. It had a large main or grand staircase, I guess you would call it, that was identical to this without the bottom winders here. It also had a second spiral staircase that went from the first floor, actually it goes from the basement all the way up to the third floor. You know, when we walked the project with the architect, she kind of said, hey, you know, there's nothing up here on the third floor right now. Why don't we match the staircase below and create this large well opening from third floor down to first floor? So that really gave us a good jumping off point for this design, and we kind of took it from there and ran with it.
Let's kind of like walk through some of these features. I see that the risers are mitered into the, is this an outside stringer, outer stringer?
Yep. Outside carriage, outside stringer, a lot of different terminology in stair buildings. Typically when we build staircases, we're doing 2x12 stringer that's laid out 12 inches on center. And then it's a lot of work after that to get to your finish, where with the house stringer, your frame is your finish, which is really great. So this, you know, this will go in and it's ready for paint and it's ready for finishing on these treads.
So can we take a look at that stringer on the inside here?
What we did here, we liked to go with an 1.5-inch wall stringer. We do have a lot of wiggle room on this site, so 1.5 inch gives us the strength we need, and it also allowed for our housings here, which are 1/2 inch deep. So we still have a solid 1 inch of material on the back side of these housings. And you'll notice we cut the guys cut these wedges here. These are, the ratio for these is 1:18, so if you were to take a 1 inch tall piece of wood and rip it 18 inches long at that angle, it's about a 3-degree angle, but we accounted for these 3-degree wedges in all of our housings for our treads and our risers.
So let's kind of, let's put that on hold. I want to dig into that a little bit deeper, but with these stringers here, the stairs are wide open. Are there going to be any additional stringers on the underside of the staircase? Yeah,
so you know, a lot of the old timers, when they would build house stringers like this, sometimes they wouldn't even put a center carriage, as they would call it. You know, after walking on these and moving around, they do have a little bit of bounce to them, so we are going to be installing at least a center carriage, and then depending on how that feels, we may install a second one. So we would be back to our traditional, 12 inches on center roughly. It's a 3-foot wide stair. But we will end up installing at least one, maybe two of those carriage in the center.
Cool. And what is the reasoning for this rabbet here?
So this is a detail we decided to do. It was really for a plaster detail. So this is a 3/4 inch deep by 3/4 rabbet. It was just half the thickness. That's why we went 3/4 on the width here. But this will allow us to. Once we get in the field, we'll have a similar cleat like this on the wall when we set these, and we'll actually span all the way across with some strapping or some framing, so that when the guys come into board, they're able to fasten right to this edge and then put a stop bead here and plaster this flush.
Nice. So this will just be one smooth transition going across?
Yep. And the other thing on the existing staircase, there is actually a bead detail that carries on the exterior face of this skirt board. We've been playing around with the idea of possibly doing that on this as well. Mm-hmm. It could get tricky though, especially up at the top here. We have a well cylinder that the guys built, which is going to be curved. It's got you have this rake angle on it, which is much different than our straight run here.
Let's get back to the housing. Is that what you called it?
Yep.
So these treads, they look like they're just butt right into that stringer, right? But they're not. No. And I know this because I've been watching the guys here in the shop fabricate this. So what's actually going on inside here?
When we laid out these housings, obviously we knew the rise and run up our stair treads and risers. So what we did is we allowed for that 1 to 18 pitch on our wedges, and that's the shape that we actually routed a 1/2 inch deep into this skirt board. And what the wedges and these housings allow you to do is obviously insert your tread into your wall stringer, and then those wedges, when we drive them through the back, it actually forces everything super tight. So it's tough to see, but the joint is super clean. And the main reason was to get this joint very tight, because we always struggle with this. Adding a skirt board, if we were to add it on top, it's a very tricky detail in order to get this tight. And then sometimes you got to put it in ahead of time. This just ensures that you're super tight, and those wedges driven into the back and the underside actually puts everything into tension over here. I got that from Ian. But it just allows for a very strong stair with very tight seams, and all the wedges are all glued when they're installed, so nothing should ever move.
While we're kind of looking at these treads from this angle, I see. Is everything pre-primed? Just where your edges are going to lap?
Yeah, so the guys went through, and this has kind of become standard for us. It's you can't deny that things move with the seasonal changes, and there's nothing worse than having raw wood that you didn't prime, and we're going to be adding some 3/4 Scotia molding beneath this to finish it off, and we really didn't want anything to move. And if you have a paint line and it separates, it would stick out like a sore thumb, and we're just trying to avoid that. And this is something that the guys did. They do. I didn't even have to tell them to do this. They just know, and it's a great detail. And
yeah, this is actually the same. Yeah, this is actually the same thing that we do with our cabinet doors. So when we're fabricating a door, we'll pre-prime the panel before we assemble the actual shaker door.
Right.
For that same reason, the wood movement, and just so you don't have that hard line of an unfinished material.
Yeah, and it's something that's super quick, and it takes a few extra minutes, and it's well worth it.
So another thing that's catching my eye over here are these curved skirt boards. What was the idea behind these?
Between digging into a few different books and doing some of my own research, this is what the stair builders would call easing. Mm-hmm. And what it is you have your rake angle here, which is what we would call the rise over run. This angle here would be your rake. And then down here where it flattens out, we knew we had to transition into our winder down here. So if you look, the top of this stringer is actually flush with the top of this stair here. So when I designed this in CAD, I essentially pulled a level line across here. I also pulled down my rake angle here with a 2-inch offset here for our cap to go on. And then I did, I pulled a tangent arc from this end and set it up here on the rake. So it's tangent where it meets here, and it's also tangent where it ties in up here. And that's what they like to call easing. And we did that for all 3 of these wall stringers. We used rough sawn poplar. It was 8/4 what we started with, and the guys actually milled it all down here in the shop down to 1.5 inches. And then, since this was drawn in CAD, I could give them a drawing that showed the different glue ups and lengths and widths that we needed to make sure that we came out with a full piece here at the end. The ends of this main wall string are about 15 inches deep on either end, and we're about 10 inches in the middle here.
Do we have any of those drawings we can take a look at?
Yeah, absolutely. This actually shows you all of the different housed routings that we did, and this actually is a drawing of that glue up for the easing we were just talking about. So in these shapes, they do look weird, but like I said, this is not only for the tread and riser, but it's also for a wedge for the tread and a wedge for the riser.
I know from the cabinet side of things, having drawings this detailed is super important. You know, when we're building stuff, we don't have drawings like this. You know, we're not outlining what our glue ups are going to be, but I mean, for something of this magnitude, I would imagine that's crucial.
Yeah, Ian had a lot of experience, and him and Patrick really did a bang up job here on fabricating this thing.
So I want to go back actually to this drawing here, and so I'm looking at, you know, this piece here. What would you call this particular piece? Is there a specific name for that?
Yeah, so we call that a well cylinder.
You guys are doing something different here. Let's walk through that.
So this is going to be our lower well cylinder. It's actually sitting in a little jig that Patrick had fabricated so that he can clean up the interior face of this.
And how are you doing that? Are you hand sanding it or using an orbital sander, or what's the process there?
So it's going to be a combination of hand scrapers as well as you know, orbital sanders, and maybe a little bit of hand sanding as well.
While we have this kind of curved shape, it doesn't really look like that picture. So how are we going to cut that?
So this one will actually be cut into a quarter. So we're only going to use 1/4 of this, and we could take a walk over to the staircase in a minute. But what we'll do is we'll end up trimming this down, and we're going to cut our rise and run into the cylinder as well. Now, you know, without really diving into it, you look at it and you say, how are you going to cut that? Well, it all goes back to math. So what this is we actually use 30 different staves to make up this complete cylinder. We have another half that'll be the upper well cylinder. And
when you say stave, you mean they're individual pieces with an angle cut on both sides?
Yeah, correct.
Okay.
So for us, you know, it was about a 6-degree bevel on either side of these. Worked out to be 30 pieces.
So as we're building those up, we get this curved shape naturally.
Correct. Yeah, and you know, we had a very specific diameter, obviously, that we needed to hit because we are matching existing.
And that's what this template here is?
Yep. And you know, we already have the stairwell opening framed on site, so it's really just waiting for us to install this. But next steps here, the guys are actually going to cut this into a quarter. The one at the upper well will be a full half circle. But like I said, you know, it looks intimidating when you look at it and say, how are you going to make that? But it really just comes back to math. So since this is a half circle, you know, we can pull an axis through the center here, and we know that our winders are set up at 30 and 60 degrees. So we can simply snap, you know, a 30-degree and a 60-degree line. We make that cut, you know, the depth of your rise, and then you just simply tie in.
Do you use what, a jigsaw, a circular saw? What?
We're probably going to end up using a combination of circular saw, table saw, something like that in order to get those cuts dialed in, because this will need to be mitered into our risers at the top and bottom.
So that it matches the. Let's take this over there. Let's go take another look back at that staircase so we can kind of put 2 and 2 together here.
So as you can see here, we already have the shape started. You know, these returns on these nosings were cut to the same radius or diameter to give us this shape. So when we cut this one into the quarter, you'll notice that the face of this riser would be one axis, and the face of this riser is another. So what I was saying, you know, if you locate the center point of your circle, you know, you snap 30, it gives you the face of this riser. 60 will give you the face here, and then you simply miter it and we slide it in theoretically.
So that one's gonna sit, what, right under here, flush with this?
Yep, so it's essentially, we're gonna have a knife edge, or we've been talking about a detail on how to kind of make a clean joint here and have everything flow. But essentially it would stop right beneath this nosing, and it would be right in line with the face of this riser here.
So this is really something. I've really enjoyed watching the guys kind of start to fabricate this stuff, and I love the curved aspect of this. But another big thing here is this is going to be wide open, right?
Yep.
So at the top of that winder there, how does that get supported?
So what we did is we decided to go with a flitch beam. So if you read through some of the older stair books on stair building, typically what would happen is you would have a newel post here. We didn't want that because we want this cylindrical shape here. So we needed to come up with a solution in order to hang this upper landing and support the whole staircase. So we decided to go with a flitch beam here. We actually had this cut on the CNC for our rise and run, and then the guys came in and put our miters on here so that they meet the back of our risers where they should be. So up at the top here, this will actually be hung off of our, our double 2x10, 2x12, whatever we have there for a beam. That's going to be, right where your railing is going to fall. Mm-hmm. And then over here, if you look, you can see that this beam projects past the backside of our wall stringer, and we're actually going to beam pocket this because the party wall that this staircase is going to be hung off of, it's a brick party wall. So we'll end up creating a beam pocket that will use some non-shrink route and secure that end. And like I said, this end will be hung so we are solid at the top, and we get to eliminate that newel post or any kind of support coming all the way down. So this will be all open, and we're going to do a really cool plaster flare, curve, whatever you want to call it, so that it looks very seamless and it just flows up into the third floor or second floor ceiling here.
So let me ask you one more question. Mm-hmm. This staircase here in our shop is huge.
Yeah.
How do you plan on getting this into the unit?
Good question. So we're going to break this down into 3 pieces.
Just 3 pieces?
Yep. Well, I shouldn't say 3 pieces. It's going to be, we like to think of this staircase in sections. So we have our main section. This is all glued. These treads, risers are already glued up completely to that long wall skirt.
So this middle section from this tread?
Yep.
Up to the next square tread?
Yeah. So all 10 straight treads are already completely fastened. These miters are all glued, and they're glued into our stringer there. So that whole stringer, it's about 18 inches out, or 18 feet out to out. With these treads, that'll be one piece. And the wall stringers on either, the top and bottom, as well as all the winders are going to come out. So we're just going to be dealing with this bad boy.
So what's the plan on actually physically getting this into the house? Do we have to get a crane to lift it through a window? What's the plan here?
No, so what we're going to do is, it does look like it's really heavy. The guys have actually lifted it, with just the 2 of them here in the shop, and it hasn't been that bad. So our plan is we're going to load it up, bring it over to site, and we're going to hoof this thing in through the front door and partially up the first flight of stairs, where we'll then have some straps, and we'll have a beam with a chain fall up on the 3rd floor, and we'll hoist this thing up through its opening and hopefully land it there with no issues.
Wow. Well, that will certainly be something to see. And I think you guys watching, stay tuned for a future episode where we will show this thing installed, right? Let's come back, let's revisit this, and have you back and join me again, and we can discuss kind of the final install.
Looking forward to it.
So as always, shoot us a message. Let us know if you guys have any questions, drop some comments, and subscribe. So before you guys go, I do have one last question for you. As Nick was walking me through this, I can't help but think, what are you guys using? Are you using house stringers like this, or do you typically go with a traditional stair build? Let us know in the comments below. No pressure, no diamond, right? That's the new one.
Are we going to ask again?
Nah.
We had...
So...
Kept just looking at me laughing. I don't know.
I'm fucking asking questions here. Are these curved scoreboards? Are these curved
What's up?
Nothing. What's up with you?
That I don't really know, to be honest with you. Time for beer.